Hello. In today's class, we'll be seeing what is meant by a definite integral. Okay. So first, let's have a curve. Okay. This is x direction, and this is y is equal to f of x. Now let's have an area curve like this. Okay. So now let the beginning of the area be A and the ending of the area be B. Right? In the x-axis, the beginning of the curve is A and the ending of the curve is B. Now we have to find this shaded portion's area. Okay. Now we'll see how we are going to do it. Okay. Now in order to do it, I have one area which I know very much. Area of a rectangle is equal to, this is a rectangle, let this be a rectangle. This is got, the area is got by adding strips of very small, if you are adding sticks, matchstick, right? If you're having adding a matchstick, if you give let's say 10 sticks, you go on adding till it is 10. 1 2 3 4 5 till 10. Then if you, the matchsticks will create an area of rectangle like this. So what you have done is basically you have added many individual matchsticks which will give you a whole area. Fine. Okay. This end is called as the breadth and this length is called as the height. So area of rectangle is base into height. Okay. Okay. Now we will come to this curve. I'm going to draw a new curve because this will become congested. Okay. Wait. So now let's have a curve, right? Let's have a curve. This is x and this is f of x. This is the beginning of the curve A and this is the beginning of the curve B. Okay, now starting with the height, this height is f of A. See, this is the function of x. Here x is equal to A, so this height is f of A. Now I am going to create a rectangle like this. Okay, this is the area of my rectangle. So, what is the area of my rectangle? I'm dividing this entire curve into strips of width delta x. Okay, I'm going to divide the x axis with strips of length equal length delta x. Till here, this last segment will be delta x. Okay, so I'm divided into 5 regions. Now, let's take the area of the first curve. Its height is equal to f of A. This is the height. Breadth is equal to delta x. Now, area of first strip, that is this portion where I have shaded, right? This portion will be equal to breadth into height, which is equal to f of A, f of A into height. What is height? Delta x, which is equal to f of A delta x. This is the area of the first strip. Second strip, similarly, for second strip, area of second strip will be equal to, let's call this A1. Okay, second strip, then this will become f of A1. Okay, f of a1, so this will become f of a1 into delta x. Second, third strip, area of third strip will be equal to f of a2 into delta x. Till last strip, area of fifth strip will be equal to f of a4 into delta x. Fine. I am divided into strips. This is fourth strip and this is final strip. Now, the total area of all these strips will be equal to area of individual triangles. So, summation of area of 5 rectangles will be almost equal. This approximation of the area of the curve. This symbol is called approximation. Approximation of the curve. Approximation of the area of the curve. Now, when I shade it, see these portions are left out. See, I'm drawing once again. When the curve, let's take the first strip. Okay, let this be the curve. Second strip, third strip, fourth strip, and this is the fifth strip. Let this be the area of this curve. Now, we have covered the rectangle's area, but this is the left out area. That is why the addition of 5 triangles is an approximation. The shaded area part is left out. What we have done is we have counted only the 5 rectangles area. The area left out is not accounted into the area of this curve. This is why we are having an approximate area of this curve. Now our work is to do remove all these areas of this curve by some operation. This excess of the area should be equaled. How to do it, we'll be seeing. Now, if the same strip is I'm drawing the same area curve here, right? Instead of dividing into bigger rectangles, if I divide it into smaller rectangles, right? If I divide it into smaller rectangles, I am getting less area left out. Instead of 5 rectangles, if I divide it into 10 rectangles, then the left out area which I am shading, right? This part I am shading is less. Okay. Instead of here, there are 5 rectangles, and here there are 10 rectangles. So if I decrease the breadth of the rectangle delta x, I am getting a more accurate curve. Instead, if this is the area, right? If I am taking delta x is of negligible breadth, let's say 0.1 centimeter or any unit. If I'm taking it very, very small and adding all these strips, then I will get zero error. Zero rectangle will be left out. So I will be getting the shades as the total area of this curve. See, if you have not understood, I'll draw it once again. See, if you have not understood, just follow me. In the previous curve, what I have done is taken a curve divided into 5 rectangles. Okay, divided into 5 rectangles. These are the area of the curve left out. These are the left out regions of the curve. Instead, this is 5 rectangles. Instead, same curve, if I'm going to divide it into, let's say, 20 or 30 rectangles. See, the area left out becomes very small. The darkened region means the area of this curve left out. So when it's 20 rectangles, the area becomes the area of the rectangle becomes almost equivalent to the area of the curve. Instead, if I'm going to have 100 rectangles, first rectangle, second rectangle, third rectangle, fourth rectangle, like this. If I add all these sticks, like matchsticks, right? If I add all these matchsticks of very small width, I'm not talking about height, but very small width, then I'll get this 100 rectangles like first matchstick, second matchstick, third matchsticks. The height of matchsticks will vary, but the width of the matchstick is small. If I add all this, I'll get area of the curve, which is equivalent to area of very small rectangles. This very small rectangle, I have divided by delta x. The whole x I have divided into 5 delta x region. So when the rectangle width is very small, I call this region not as delta x but dx. Dx is equal to very small delta x. Remember, the height is not we are talking about. We are talking about the width delta x. Okay. So each of this width is f of x. See, this is f of 1, right? This is f of 2. Similarly, if we add summation, this is called addition. Okay, I'll first write it like this: a1 into dx plus f of a2 dx till 100th match, right? F of a 100 dx will be equal to area of the curve. Area of the curve. This addition, right? This addition can be simplified. Okay, 1 minute. This addition can be simplified if you use a symbol for addition instead of writing f of 1x, 2x, 2x till 100x. I'm going to write it as a symbol which will mean summation. Instead of addition, I'm going to write summation. I is equal to 1 to 100 f of xi dxi. What this means is, instead of, let's say I'm going to write f of I is equal to 1. So f of x1 dx1 plus f of x2 I is equal to 2 dx2 till f of x is equal to 100 dx 100. This is simplified when we write it like this. Clear? This addition is taken care of this symbol. I is equal to 1 is just starting till this final state 100. I can write it like this. So I will continue in a new diagram. So I'm continuing in a new diagram. This entire area can be written as summation I is equal to 1 to 100 f of xi dxi. Now as the limit dxi width of the limit as the width of the limit dxi tends to become 0, that is delta x tends to become 0, we'll have many number of such strips. Okay, so that is denoted by when delta xi tends to become 0, we get summation. This is related to this term f of xi dxi by having delta xi tends to become 0. Okay, the meaning is, if this is delta xi and this is f of x. Now, when you add such different rectangles, you have the formula I is equal to 1 to 100 f of xi dxi. When the width becomes very small, here this is delta x and the width of such strip is dx now. Now, when you add such strips, you get the symbol f of x into dx. This is the summation sign. This is the same summation. When the width is large, it is summation, and now it is integral. Okay, this S is called integral. Fine. Okay, now we'll find we have found that the area of the curve is we have found that the area of the curve is equal to area of the curve is equal to summation f of x dx. Now we have to write the beginning and the end of this curve. It starts at A, ends at B. Okay, now we have to write the beginning of and end of this curve in the symbol like starting from B till ending at A, f of x dx. This, in the previous formula, this was taken care by I is equal to 1, 200, f of x, delta x, right? Delta x or dx, both are right. Now, B takes care of this ending point. A takes care of this starting point. Okay? So, this is the meaning of the curves. Now, let's have a curve like a continuous curve. It goes on till infinity. Such a curve, I need to find the area. It goes on till infinity. Okay, example is a sine curve. Now, of this large curve, I want to find the area of only a small patch. It begins at A and goes till infinity. But I want to find the area of this curve alone. What should I do? Now, area of strip is equal to integral. Now, I'm going to divide the curve into two parts. First part, I'm going to start at A, end at infinity. Second curve, second curve, I'm going to start at B. This is the area of the curve, right? Start at B and let it end at infinity. When I subtract, this is the first curve, this is the second curve. Let this be I curve. Okay, so the I curve. Now, when I subtract 1 minus 2, 1 minus 2, I'm having the curve like this. This is the first curve and this is the second curve. So when I subtract 1 and 2, right, I am getting this area of the strip, right? So what should I do? Area of the strip is equal to first curve minus area of first curve minus second curve. This curve's area, first curve area is given by f of x dx, but the starting limit is a, ending limit is infinity, minus second curve. This is second curve. F of x dx starts from b to infinity, right? So each curve will starts from final minus infinity. Okay, so each curve has to be subtracted, and so it will become f of x plus c minus f of x plus c. Now when I write these curves, right, this gives me an area f of x dx starting from A till ending at B. Now plus C and minus C cancels. When I this plus C, this is my inside minus sign. So this sign and this C gets cancelled. So I'm getting 0, f of x dx plus 0. So this is called as a definite integral. Area of the strip is equal to integral a to b dx f of x dx. Remember, there is no constant, additive constant c, because c gets cancelled. So area of the strip is equal to f of x plus dx. Remember, whenever we integrate, let's say y is equal to 2x dx, we usually write it as x square plus c. But in definite integral, when it is like 3 to 5, if you have a curve like this, it starts from 3 and ended at 5. 3 to 5 f of x dx, we will not write the additive constant. This c will not be written.